Hello and welcome all for today's discussion about high performance Apache Sqoop. So basically we are going to discuss what is Apache Sqoop and at very high level architecture of Sqoop, and then we'll go deep dive into some of the performance tips which can be used or implemented for getting better performance out of a Sqoop deployment. So that is the whole agenda. We are not going to discuss in detail different commands and all those things. So we assume that you have understanding of Apache Sqoop and you are using it, and now you want to get better performance out of your Sqoop infrastructure. So that is the whole agenda for today. Okay, so now what is Apache Sqoop? Sqoop is tool designed to transfer data between Hadoop and relational databases. Okay, so this is the crux of what is Sqoop. You have your RDBMS, enterprise data warehouses, and other source of systems, which you want to say, you want to use the power of Hadoop to do some kind of processing. You can use it. You can use Sqoop to import those data, those information, those pieces of data, which will be huge basically, to feed it into your Hadoop or HDFS kind of infrastructure, do all the processing, and then export the result back to the RDBMS and enterprise data warehouses using Sqoop. So Sqoop works both way. You can get data from RDBMS towards your Hadoop, and then you can send the data back. Okay, so that is the first point or basic summary of what Sqoop is all about. You can use Sqoop to import data from the RDBMS systems such as MySQL or Oracle into Hadoop systems like HDFS, HSpace, and Hive, etc. Transform the data once you have received it in your Hadoop system. You can transform the data, do all the processing using Hadoop MapReduce, and then export the data back to the RDBMS. So Sqoop you can use for both kind of import as well as export into your databases from Hadoop and vice versa. Sqoop automates most of this process, relying on the database to describe the schema for data to be imported. And internally, Sqoop uses MapReduce to import and export the data. Okay, which provides parallel operation as well as fault tolerance. That is the advantage of built-in advantage of using MapReduce. You will get parallelism and fault tolerance and all those advantages which Hadoop provides. Okay, so when you run a Sqoop command, internally it will go and launch MapReduce jobs on top of Hadoop cluster. Okay, so internally it will use that Hadoop and all those infrastructure which you have set up for Hadoop. So you simply run a command, very simple commands of Sqoop. Internally it will do all the creation of MapReduce jobs and all those things. It will automatically do it for you. Okay, so now we'll just discuss at very high level the floor, high level architecture. Okay. So what happens is you can use either command line interfaces, or you can use browser based clients available from third party and other such things, and then use Sqoop. You can use command or use browser based utilities will connect to the Sqoop server, okay, where you have installed a Sqoop. There are different connectors available for different databases. You can use those, like for Oracle or MySQL, Postgres, DB2, etc. Different connectors are also available. And then Sqoop has its own metadata repository where it stores some kind of metadata which you can also access as part of your commands if needed, depending upon the requirement. Okay, so what happens is once you run your command, okay, internally map jobs will be launched. Okay, so MapReduce framework will come into play. Map jobs will be launched, and say you are getting or you are importing data from your RDBMS system. So what map jobs will do, they will get the data in parallel and start writing those CSV files or whatever format you choose into your HDFS storage. Okay, so it can be anything, but for simplicity's sake, let's say it's writing into HDFS storage. So you run a simple command, very simple SQL like, it's not actually SQL like, but very simple plain English commands. It will automatically go and launch the map jobs, and it will start writing individual files onto your storage, underlying storage. Once you have done all kind of processing into those files, you can use Sqoop again to send data back to your enterprise data house or document systems or RDBMS. So this is the overall high level Sqoop architecture. Hope it's clear. You guys must be knowing it because we have this, as I said in the beginning, we are not going to discuss detail about Sqoop. So it's just a brief summary of the Apache Sqoop architecture. Okay, now the crux of this discussion, which is performance tips for Sqoop. So we are going to discuss some of the performance tips or tunings which you can use to get better output from your Sqoop job. So tip 1, always import export the required data. Use where clause wherever possible to work with the required subset of data. So Sqoop is very simple yet very powerful framework. You can use it to pull as much of data you want to, but make sure whenever you are pulling a huge amount of data, you don't pull unnecessary or you don't export unnecessary data. Always use this particular parameter. It can be nested definitely. I've just given a simple example. So use Sqoop import connect and whatever is your JDBC URL, okay, table name and the condition. Okay, same way always specify the columns with hyphen column tag or attribute or parameter, whatever you call it. So make sure, so crux of this performance tip 1 is you only read or you only import or you only export data or records which are needed, and you only read or export back columns which are needed. No unnecessary rows or columns you are getting into the system or bringing into the system. So this way you can always fasten up your processing, your network transfer will be reduced, and all those things, it can improve your performance. Tip 2, to reduce the size of data to be stored in HDFS, use comparison or say Hive, etc. You can always use and go and use compressions. How do you compress the data? Simply use compress parameter with your query. It's a very it can, depending upon the type of compression you are using, it can reduce the size dramatically, but there is a catch. Say if you are importing the data, there are different kind of compressors available, splittable as well as non-splittable. Okay, so if you are using a format or you are using a compressor which doesn't allow your compressed file to be splitted, if it can't be splitted, then Hadoop will not be able to process data in parallel, right? You have compressed it to say, I'm just taking a number, 100 MB file, okay, of original say 500 MB, you have compressed it to 100 MB, but somehow you have chosen as compressor which don't allow this 100 MB to be splitted across different nodes so that Hadoop can process this in parallel. Okay, if you choose such kind of format, then further processing, it might be impacted because now Hadoop has to do sequential processing instead of parallel processing. So in that way you are going to lose the major advantage of Hadoop. Okay, so make sure you are using compressor which are splittable. So performance tips 3, number 3. Okay, so to transfer to fasten data transfer, prefer to use direct mode, okay, rather than standard JDBC interfaces. Okay, so most of the database providers, especially open source and some big vendors also, they support their own utilities and drivers where you can directly pull the data or export back the data using direct mode instead of using standard JDBC interfaces. Okay, so they uses these utilities and these drivers, they basically uses some DB specific or RDBMS specific APIs or utilities which can fasten up the transfer. So always if available, always go and use direct mode. Okay, so you just specify hyphen direct, and depending upon whether you have perfectly set up the driver or utility, it will work. Only thing is that not all database vendors, despite they support or provide this utility or drivers, but most are already doing it, and many more are continuously they are providing this. So now there is a very good ecosystem which provide this kind of utility. So always prefer to use direct mode. Okay, so next is, as I said in the beginning, Sqoop internally launches map jobs, right, to pull the data in parallel. Okay, so you can always go and decide or how many concurrent numbers of map jobs you want to be launched. Okay, by default it's 4, but you can always go and change it using this parameter. But you have to be very careful. Okay, suppose you change it to 10 now. So 10 queries or 10 basically independent map jobs, they will be connecting to your database and start reading this if you are doing an import. So you have to make sure that you are not overloading your source database, otherwise your performance can be impacted. Your main RDBMS system can be slow, because now larger number of clients are reading the data or writing if it's export. So you have to be very careful while increasing this. But yes, this can definitely improve your performance if you have your source system is perfectly tuned to handle more queries, more concurrent reads from different map jobs. It can definitely improve your performance. Okay, so next step is always use incremental imports. Okay, incremental import is that you have say imported already 100 records. Now why do you want to unless there is absolute business requirement or there is a business use case for this, you always start with the 100 first record, right? You don't have to unnecessary maybe delete old data and then pull 100 records again, then 100 first. So always try to use incremental imports. So basically you have limited down the data you are going to read or export back to the RDBMS systems. Another is use batch mode. Okay, so batch mode is we all know it's one of the very powerful feature now supported by all the JDBC compliant databases, because it's part of JDBC interface. So though implementation can vary across different RDBMS, and each RDBMS can give a different performance gains when you're using batch mode. Okay, so make sure you batch is basically you combine different statements, and instead of sending individual record or in individual insert statement, you combine say 100 or whatever number you decide, and then you send those across. So depending upon how different RDBMS vendors handle this, you can have different performance gains. Okay, so the next tip is about again kind of sending or committing multiple transactions in one go. So if you use this particular property while you are doing the export back to the RDBMS systems, so if you use sqoop.export.statements.per transaction property, basically you are specifying how many rows will be inserted per transaction. So if you say this property, you set this property equals to 10, so a database will insert 10 transactions and then it will issue a commit. So implementation may vary across RDBMS and can have very different performance gains depending upon how RDBMS are different RDBMSs are implementing this. You can have different performance gains or even degradation. Okay, so you have to be very careful while coming up with the proper number for this property. You may have to do certain testing before you finalize the number. Why degradation can happen in certain scenarios? Because now your transactions are being kept in open state for longer duration of time. So by default one insert was happening and commit was being issued. Now if you set this property to 10 inserts will happen and then commit will happen. So your transactions are basically being kept open for a longer duration of time, and if you have multiple open transactions, your degradation may also performance may also degrade. So you have to be very careful. Another very another very important parameter is split by. So if you specify this, okay, you basically, if you don't specify this, generally what Sqoop does is it uses the primary key, and say you have 100 records in your databases which needs to be, say, pulled into your Sqoop. Okay, so if there are 100 records and by default you have set up 4 map jobs, so first map will pick up 1 to 25, then 26 to 50, 51 to 75, and 76 to 100. But somehow if that primary key is not evenly populated, say first set of 1 to 25 doesn't have actual 25 records, but say 10 records or 5 records, same way second is more populated, things like that. So when your primary key values are not properly or evenly separate, scattered out across different map jobs, some of the map jobs will be running with less amount of data. So that may cause some performance issues in your system, because now you are not utilizing map jobs to their maximum limit. So you can specify your own key by using split by, and this way you can always do the load balancing of map jobs to process almost equal number of records. Okay, so this is the important, very important in certain scenarios where you can specify this key, and it will automatically ensure that individual map jobs, they are possessing equal number of or almost equal number of records. So here is the final set of instructions or performance tips. Sqoop is based on Hadoop cluster. It runs on top of your Hadoop cluster. Okay, so same way you use Sqoop to read or import data from RDBMS systems, your enterprise data warehouse systems, and use that data to write that data to underlying Hadoop, HBase, Hive, and many more such components. Do some processing and export back to your RDBMS or enterprise data warehouse systems. So, and data will be huge definitely. So because all these components are involved, Hadoop cluster is involved, your RDBMS and data warehouse systems are involved, HDFS, HBase, Hive, depending on where you are writing it, and volume is huge. So all these components should be tuned for better performance. It's not that you have just mentioned few of the some of the tips we have discussed so far, and your Sqoop will be faster, automatically faster. Yes, it will be, but there are components which are in the overall ecosystem. When you are running Sqoop, there are components which needs to be tuned as well. For example, if I am writing large number of records in RDBMS, okay, so I have to ensure that my RDBMS table is designed to handle those concurrent writes at that particular volume. If my RDBMS itself is a bottleneck, then no matter how many how much tuning I do at my Sqoop level, the export is not going to happen at faster rate. So I have to ensure that my RDBMS is designed to handle those concurrent reads, appropriately partitioned, so that different partitions are handling the concurrent writes. Disk storage is also optimal, so that all the writes are internally not going to same physical disk, and thus that particular disk itself is becoming the bottleneck. So I have to ensure all those components are properly designed for better performance. Same way, if I am writing to HBase, concurrent writes are happening, multiple huge volume of writes. I have to ensure that my HBase table is scattered across different regions. If it's on the same region, that itself will be the bottleneck. Okay, so summary is that apart from some of the options or parameters we discussed, I have to go and tune my Hadoop also, RDBMS, and all those components. Only then I am going to get end-to-end better performance. So yeah, that's it for this discussion. If you guys have any questions, any doubt, just leave in the comment section, and I'll revert on that. Thank you very much, guys.